Hello everyone. So in today's video of chapter solid state, I'll be talking about extrinsic semiconductors and doping and magnetic properties of solids. Extrinsic semiconductors and doping. The conductivity of semiconductors can be increased by doping. The process of addition of minute quantity of impurity to a semiconductor to increase its conductivity is called doping, and the added impurity is called dopant. A doped semiconductor having higher conductivity than pure intrinsic semiconductor is an extrinsic semiconductor. There are two types of extrinsic semiconductors. Number one, N-type, and number two, P-type semiconductor. Now, what is N-type semiconductor? N-type semiconductor contained increased number of electrons in conduction band. An N-type semiconductor is obtained by adding group 15 element to intrinsic conductor or intrinsic semiconductor which belongs to group 14. For example, doping of silicon with phosphorus. Silicon has a crystal structure in which silicon is linked tetrahedrally to 4 other silicon atoms. When small amount of phosphorus is added to pure silicon, the phosphorus atom occupy some vacant site in the lattice in place of silicon atom, which you are seeing in this diagram also, and overall the structure of silicon would remain unchanged. Now 4 of the 5 valence electrons of phosphorus usually make bond with the silicon atoms, but phosphorus has one more extra electrons since it is containing 5 electrons in an outermost shell, and it is one extra electron. Therefore, silicon doped with phosphorus has more number of electrons in conduction band than those in the conduction band in the pure silicon. It is thus transparent that the silicon conductivity is doped with phosphorus and is higher than that of silicon. The electrons in conduction band move under the influence of applied potential and conduct electricity. Because the charge carriers are increased by the number of electrons, silicon or germanium doped by 15th group element like phosphorus, arsenic, antimony are N-type semiconductor. Now, P-type semiconductor. P-type semiconductors is produced by doping a pure semiconductor material like silicon or germanium with the impurity from group 13. These elements contain less number of valence electrons than the pure semiconductor. Consider the example of boron. Boron is the element belong to 13 group, and it is a dopant, and it is doped with pure silicon, which is a semiconductor. Now, the boron atom occupy normal position of some of the silicon atom in the lattice, which you are showing in this diagram also. Boron atom has only 3 valence electron, so it does not have enough electron to form bond with 4 silicon neighbor. So in this case, what will happen? Boron form only 3 bond with 3 silicon atoms. As you are seeing, it is forming with this and with this silicon atom, but one hole is created, or missing 4th electron creates an electron vacancy, which is called as hole. A hole has a tendency to accept electron from its close vicinity. Thus, a hole behaves as it is a positive charge, and the electron in partially valence band move under the influence of applied potential, and the hole move in opposite direction. So this is about P-type semiconductor. Now, magnetic properties of solids. Magnetic properties of solids can be understood easily in terms of classical picture of electron. The electrons spin about their own axis, and the spin of electron acts like a tiny magnet because their spinning action generates induced magnetic field. If an orbital contains one electron, the unbalanced spin exhibit magnetism. When the electrons are paired in the orbital, so there would be no magnetic property observed. On the basis of magnetic property of solids, on the basis of magnetic properties, solids are classified in three categories: diamagnetic, paramagnetic, and ferromagnetic. Now, diamagnetic. These substances are having all electron paired, are weakly repelled by magnetic fields. These substances are called diamagnetic. Pairing of electrons balancing the spin pairing of electron balances the spin, and hence they cancels their magnetic moments. Examples are nitrogen, nitrogen gas, fluorine gas, sodium chloride, water, benzene. These are diamagnetic substances. Paramagnetic solids, the substances which have unpaired electron and weakly attracted by magnetic field. These substances are called paramagnetic substances. The spinning of unpaired electron gives rise to magnetic moment. The substances are attracted by magnetic field because of magnetic moment, and these substances exhibit magnetism in presence of external magnetic field only, and they will lose their magnetism when external magnetic field is removed. Example: oxygen, cupric ion, ferric ion, chromium ion. These are some paramagnetic substances. And now the last, ferromagnetic substance or ferromagnetic solid. The substance contain large number of unpaired electron and are attracted strongly by the magnetic field. These substances are called ferromagnetic. The substances can be permanently magnetized. They retain magnetism even after the removal of external magnetic field. Some examples are iron, cobalt, nickel, gadolinium, and chromium dioxide. So this is all about magnetic properties of solids.